Okay, let's get started with SACS. So for starting with SACS, open the SACS module. So you will get a pop-up for selecting the license. I would suggest always select the lowest license because there are other licenses involved and the license will be charged according to the usage. So in order to reduce the cost of the licensing, I would suggest always select the lowest license, and whenever a higher license is required, SACS will ask you to select a higher license during the running. A pop-up window will be coming. So now I am selecting the base license and I am clicking OK. So once I click OK, I will get the SACS executive pane. So here I will be having the program launches. Then here I will be having the folder and the files which I am working on. And here there are settings. And then here there is like you can access the folders, you can access the manuals, and if you want to have the analysis summary you can obtain it from here, and if you want to create a multi-run generator you can access it from here. Now let's take a look at the settings. In the settings there are different options. You can select the default section library. There are a lot of libraries involved. It will be varying from region to region which you are working with. And now coming to here, you can select the default license whichever is required. And the second important thing, if you look over here, is the units. So units you can set whether it's English units or metric kilonewton force. You can select it over here. And then what you have is um okay, file name settings. So in the file name settings, there is a difference from the SACS files, from the conventional files. Let's say if you have any PDF document, let's say book1.pdf. So always the extension comes after the name. But here what happens is, as a default, the extension type will come first and then the name. So file type .id. So this is the default value. Anytime you can revert it, but I would say keep the default one so that it would be easy for someone who is working on your file. And for example, you can see this is dyn input dot mod. So this one is the name and this is the extension. Now if you want to understand what file this is, the name changes. A name have two components. So first one is a program label, the first few digits, and second one is a file type. Now let's take the case of dyn input. So it tells dyn is a dynpack file and inp is a input file. Similarly for the SAC inp, it's a SAC input file. So if whenever you get a file and you are get confused with what type of file it is, you can always come over here and you can take a look. Now click OK. Now create a model. We have two options. So we have a modeler options which you can work on 3D, and there is a data file option which you can work with the notepad style of input. So for the beginners, I would suggest you go to modeler. Once you click on modeler, it will ask whether to modify an existing model or create a new model or open last model. I am going to create a new model. Click OK. So here there are two options, start option and the units. Unit, I am already keeping my default as metric with kilonewton force. Then the start option, it will ask me for two sub options. It will be like start blank model and start structure definition wizard. Structure definition wizard will be useful when you are going to model a jacket type of structure, but here I am going to model a simple cantilever beam. For that, what I would do is I will go to click start blank model and click OK. So now this is my modeler and it is called proceed. So when you look at the modeler, the default, come to the settings. So you come to the settings, and here in the settings you may have a window something like this. So it will be like black background. I'm not a fan of having a black background because if you want to put screenshots in some reports it will be having a black background, so I always prefer to keep a white background. To do that, you can do is come to file, come to settings, and here in the display you can select the top and bottom backgrounds as white. And when you change these two as white, you need to change the join labels as black. Okay, rest of the things you can keep it same. And if I click OK, this one got change. Now there is one more thing with the settings. It's like the units. So units, so when we give the input in the SACS, it will have some default units over there. So if you look over the first two lines, it's like tubular OD and wall thickness for member groups. The default unit is in centimeter. So at any point of time you can change the unit when you give the input. Now let's say if you are working with few mm's or centimeters in or meters, in that case you can always come to the default unit value and select it. You can change it from here. If you want to change it to you can change it from here. Now let's say if your pipe values are given in inches, you can select it over here. So you have the liberty to change it at any point of time. Okay, so now I am not going to change anything over here. I will keep as such. Now what I am going to do is I am going to create a cantilever beam, and it is having some loads acting on it. Now how to start? So when you look at this window, this is the home window which is getting as options from some main options from all the sub windows. So from here to here it is like display. Then from here to here it's for creating joins. Here to here members, plates, member groups, it goes like this. So this is like quick access of all these options. Now if you want to have more detailed options to be accessed, you can always come to the separate tabs. So this is like for display, this is for joins, this is for members, plates, shells or solids, properties, to define it, loads, weights, environment. It goes on like that. But now in this class, we are not going to all these detail. We are going at very basic thing. So first I need to add a join. That's my primary thing. So always remember SACS Act. The modeling starts with a joint, and then we will go to the members. Now to add a joint, I can always come over here, because first thing I want to give the absolute coordinates value. Now I am going to create a join name. So join name is 4 digits. You can either go with numeric or alphanumeric. Now let's say I want to give the name alphanumeric. I can always give alphanumeric. Now here I can specify my coordinates. So I am creating a joint at 0 0. So even if you kept it blank, it will take 0. Now this will come to the fixity. There are different fixities over here. This one we will deal with it once we finish the modeling. So now I am keeping it blank, and if I click apply, so now you can see there is a joint over here with the X. So if you want to see the joint name, you can click over here. It will show the joint name. Now if you want to see the fixity of this joint, you can come to display and click on this one, joint fixity. Now at the moment I didn't give any fixity. It's like free. The joint is free to move in all three, translational and rotation. So it's not showing over here. Okay, now what I will do is I am going to create a cantilever. So this is, always look at the global coordinates X, Y and Z. Now I am going to create a cantilever beam of 5-meter length. Or so for 5-meter length, what I would do, I am going to create in the X-axis. Either I can come over here and just change it to 5 and click apply. It will create a joint. Okay, it will create a joint, and you can see the distance. Come to joint, go to distance. You can see the distance 5 meter. Or there is another way. So to use another way, it's like you can go to relative. In the relative, what I am going to tell is, okay, then joint numbers will be automatically incremented. If you want to revert back, you need to edit it. So I am telling relative to this joint, in the x-axis, I need to have another joint at 5 meters. So if I give like this, it will create another joint. Now I have two joints. So now I need to define a member. When we define a member, it have two properties. One is section property showing its cross section, and it is another one is the material property. Now going to section properties to define it. So there are two approaches. Either I can create a member and then give the property, or what I can do is I can select the property first and then create the member. Anything is fine. Now I will show you. Now let's say I am going to create a member. So come to member, there is an option called add. So here if I come, I select my first joint, I select my second joint, and I name a group label. So if I am giving a group label called BM. So there are two types like individual and string. So individual is like we will select two joints and apply it. String happens means, let's say I want to connect few members and I want to connect a few joints and with members with a continuous. So to do that we can use string. So here what I'm going to do is I am just going to click the individual, but if you want to see I will show you that as well. Now this is individual. So if you want to see the member group, you can click on here. It will show the member group label. Now what happens is I want to define this beam member. So for that I should go to property. So in the property, if you come over here, there are defined groups and undefined groups. So if we provide a member and if that group property is not defined, it will be shown over here. So if I click on this one and if I want to add a property, you should come and click add. Okay, so here a pop-up window will be opening. So here I need to define my member group. If I want to make it as a let's say I want to create a I beam, but let's say if you want to give an like a pipe, so you can always come over here. I am telling my pipe outside diameter is 10 centimeter and wall thickness is of 1 centimeter, and here it's the E value, G value, Fy. Always keep an eye on the units. Now let's say if I want to make it 355 MBA steel, I want to make 35.5. Here is the density, and if I, so this is the default color, and if I click apply, it got defined. Now let's say if I want to see it in 3D, so if I click on the toggle wireframe option, it will show it in 3D. Okay, so that is, so you can see the default color. It will not show us hollow, it will show us a solid road. Now what I want to do is I want to change it to an I-beam. So to change it an I-beam, we have different approaches of doing it. So for that, what I would do is I will come over here, come to edit. I want to make it as an I-beam. So what I will do, I will to general, and here there is something called a section label. So if I click on it, it will open a pop-up window. So this pop-up window will be showing the section labels which we defined. Now let's say I want to select something from the library. So I will go to library, sections library. So this is from AI section library. Here I can make a filter of, let's say, white flange. So in the white flange I will come over here and I will select a beam type of let's say W, maybe I will select W1677. So if I click on this one and let's say I want to change the color, I can always come over here and change the color of it and click apply. So my beam has changed. Now let's say if you want to create a plate girder or another type of section which is not in section library, what you want to do is you can come over here, member section. Here either you can copy some beams and define it. I will show you how to do it. Let's come to same white flange W16. W1677. Now let's say you want to copy it and edit. So for that we need to always change the name. So I am changing the name to beam 1. It will go up to 8 digits. Okay, for section library. If I click OK, this beam 1 section will come over here. Now let's say if you want to modify from here, you can do that. Or what you can do is you click on this one, you click, I'm adding a new beam like beam 2. So if I click on add, it will ask me what type of cross section I need to provide. So I can, let's say I want to give a plate girder. So here I can define my width, my height, web thickness, and it will be coming upon. So and then you can change at any point of time. So once, let's say if you define some beam, you come over here, and if you want to change the section, you can always click on these 3 dots and you can go to model. So here it will show all the sections which we defined external from the member. So you can select over it and change, or if you want to change from library itself, you can come here and change it. Now I am not going to change it. So this is regarding the modeling. Now I want to give the boundary condition. So for a cantilever, what I am going to do is I will make this joint fixed and I will give loads on the member. To make this joint fix, you can always give the joint fixity. To give the joint fixity, either you can come to joint properties and give a fixity, or there is another option called fixities over here. You click on it, you can give the fixity. Now when we look at the fixities, there are like 0 0 0 0 0. It goes like 0 0 0 0 0 0 0 1. So this one means the joint is free. This one means we are fixing the joint in all translation and rotations, and this one is like for pinned support. So now let's say if you want to support only in the Z direction, then what you need to do is you need to give a fixity like this 0 0 1 0 0 0. It will make the fixity only in the Z direction. Now if you click apply, and if you want to see the what fixity you have given, now you see when there was no fixity, the joint was shown as X, and when there is a fixity, the joint is shown in a pyramid shaped. Now if you want to see this fixity, you can always come over here to display, and here in the joint fixity it will show what fixity I have given. Now since I want to make it a cantilever, what I would do is I will come over select and I will make it fixed. Okay, so my boundary condition can always come over here, and if I want to change a name, I can change the name over here like demo 1. So now I have assigned all my properties over here. You can see, come to member. So I have assigned my property. So everything I can go and see like this, what are the sections, everything I will be able to see. Now I want to give the effective length. So there is a requirement in SACS. You need to provide the effective length of the member according to the loading. Now if I look, this is a cantilever. For giving the cantilever, the effective length will be 2 times. So for that, what I would do, I will go to property. In the effective length, for my LZ. So LZ and LY will be based on the local axis of the beam. So if you look, this is the local axis. So in the local axis, the X will always run from first joint to the second joint of the beam. So you can see this is the first joint and the second joint. So positive X-axis will always run from first joint to the second joint, and then the Y-axis will be defined by the right hand thumb rule, and Z will be always going up, and our LY will be like how the beam will bend in the Y-axis bending, and LZ will be, so here we can have buckling option in effective length. So I'm going for the effective length, not the K factor. So this effective length, when LY, when the bending occurs in a plane perpendicular to the Y-axis, how it will be acting. So this one will be like a cantilever. So it will be twice the length of the beam effect will be the effective length. Similarly, when the bending happens about the Z axis, what I should give, it will be also twice because it's also cantilever. So to assign this, either you can give it directly over here, or there is a way, like you go to property, go to effective length. So here you can select both the Ly and LZ, or Ly individually or LZ individually. Now there is a length factor. So whenever your member acts like a cantilever, select the length factor of 2. If it's a simply supported, select length factor of 1. Now select 2. Then what it would do is, you select the first joint and you select the second joint. Now if you apply, okay, now you then select the member and apply it. Now if you come over here and look at the member properties, you can see the effective lengths are updated. Now let's say in some cases you may provide the offsets and the real length of the member may be shortened, or it may be longer. In that case, to capture it accurately, you can use this option, use the member length instead of distance between two joints, and SACS will take care of the member length. Now coming to the joints. So now we have given the boundary condition, we have provided our model. Now what I want to do is, I want to give the loads. First one is self load. To that, what I would do, I will come to load, I'll come to self weight, and here I can define a load. Always in SACS, when you give a load, there are two sections. One is load condition, that is the major section, and then load ID, that is subsection. It is easy for you to categorize and apply. Now here I am going to define a self load, self. So here I can provide like, okay, self weight. Now here it will ask me for the load direction. Now my weight is acting in the, it is always about the global Z. So my weight is acting in the negative Z direction. So I can select over here. Now what all things to be included? So here if I select all, it will include all the structures even if I hidden something. But I want to see only what in the screen. So I will select active bar screen. Now this is the acceleration due to gravity. So our normal case, the acceleration due to gravity is g. Now let's say if you want to match the weight of some structure with some upper tensions and all, in that case you can modify the g and match the weight. Now coming to the load disposition, there are three options: delete existing load, add to existing load, for information only. So if you select for information only, what would happen is, it will show what will be the self weight. So you can see it in kgs if you want. So this self weight of the beam, and it will not assign anything. So if you go to load properties, nothing is over there. Now let's say if I go to add to existing loads, what it will do is, it will show, okay, again what is the self weight, but there is an option called keep. If you click on keep, it will be assigning. And if you come over here, you can see these are load property. There is a self load, there is a load ID, self weight, and it's applied on a member, and this is the load. Okay, and if you want to edit it, you can edit it. It is given as a UDL. Now let's say you made some modification, and if you again click on this existing load, what happens is, it will add this load again on top of what it was there. So now if you come over here and see the self weight, you can see it got doubled. So in order to avoid this scenario, what you can do is, you can use a third option, delete existing load. Now when you click it, what it will do is, it will delete whatever it was existing, and it will assign the load which is newly assigned. And you click on the keep, and if you go to load properties, you can see only the latest one is there, the previous ones are deleted. Now this one is like either to apply it as a corner joints or center load, face load, but I would say keep it at the default value. Now what I would do, I gave the self weight. Now I want to provide a joint load. So to provide a joint load, it's easy. You come over here, select this joint, and I am providing a joint name called a JNT, and I want to provide joint load ID. So I am giving a load of, let's say, minus 15 kilonewton acting downward. Okay, so joint load is given. Now let's say I want to give a UDL or a VDL. So if to give a UDL or a VDL, I can always come over here. Now let's say I will give a UDL. So here what in the member loads I will have, so this is member load. I am going to provide a UDL. So in the UDL what I would do is I am going to have distributed. So I am telling my initial load value is minus 2 kilonewton. It should act at 0.5 meters from here. Okay, 0.5 meters from here. And then the final value is also minus 2 kilonewton and it should extend for 1 meter. And now if I apply, it will apply UDL after 0.5 meters and it will extend for 1 meter. Okay, so total value is minus 2 into 1 minus 2. So that is my UDL. Now let's say I want to apply a VDL. To apply a VDL, I can do the same. I am telling, okay, this should be starting after 2 meters. After 2 meters. And it will start with minus 2 and then it should go till minus 5 for next 1 meter. So if I want to select the member and click apply. So this starting after 2 meters, then it is going for next 1 meter. And then it is coming. Now let's say I want to give a concentrated load. So for give concentrated load, there is an option. So here what it will do is, you say it's like constant. So you always see, I always use the same load condition but different IDs. I will show you the advantage of it. Now this concentrated load I am telling, okay, this concentrated load should act at so this is a constant load of minus 15 kilonewton and it should act, maybe I will reduce it, minus 10 kilonewton. It should act at a distance of um 3 meters, 3 meters from the maybe 3 meters we have, a distance of 4 meters from this joint. So if I click on this, what it would do is this load will be acting on the member at here. So no joint is created, but it will act on the member with the focal point at this joint. Okay. Now there is another option. You can give a total load. So total load is, you don't know actually what is the difference, but you want to apply a total load of, let's say 20 kilonewton on this beam. So here what you can do is, you can just click apply minus 20 kilonewton and it will apply, it will distribute it as a UDL. Now if you come into load properties, you can see one is self weight, one is joint load. When you look at the member, it have all the loads. Now if you want to edit something individually, you can see this is the concentrated, this is the total, this is the UDL, this is the VDL. So this is how you can do it. Now I have the loads, I have the boundary condition, everything. Now what happens is, when I run the analysis, each load will be acting individually for different cases. Now I want all these loads to act at same point of time. So I need to combine these loads to a different combination. So to combine the loads, what I need to do is, I can come over here. I can create a load combination. I am creating load combination called LC01, and here I will provide all these loads over here. Now let's say if you want to apply some factors like weight growth factor, so weight contingency factor of 10%, if you want to apply on the weight, you can select and change the factor like 1.1. Now if I click apply, my load combination is ready. So now let's say when you run the analysis, you will get the result for all the cases. Now you want only the result for a final load combination. In that case, to select it, you can come to options and you can come to load selection. You can click on this one and click apply. So what it will do is, it will show the final load combination for only this one. Now save it. So to run the analysis, what we need to do is, um, So what we need to do is we can go to the analysis generator. So in the analysis generator, 1 minute, let me put blank. So I can go and select the type. I'm going to do a static analysis, basic static analysis, and here I want to solve it, and I want to select the element check option. So here I can select my element check option, which code I want to look with. If I want to use for ASC 13th, I can select. If you want to have LRFD, you can select. Then NORSOC, Eurocode, British Standard, everything you can select accordingly. So I am going to select WSD ASC 13th. Now I need to activate the graphical post-processing, and I will select my SAC input file. Now let's say I have this input file over here. Now I want to change the name of the output files also to this one. In that case, what I can do, I can come over here, demo, and let me reset the output. So all the output file names are also changed as per the input file name. Now let me run the analysis. So there is no errors, and I can look at my result. So your result will show like this. And if you want to see the maximum use, because in the SACS it will be checking against the allowable limit, and it will showing as the utility ratio or unity check. So for that you can come over here, select maximum combined UC, and click apply. So it is showing our utility ratio is 0.75. And if you want to review this member, you can come over, select review design, select the member. So you see this is the individual contributions. So all the bending is happening in the Y, and these are the equations you used. If you want to see the moment diagram, you can click on this one. It will show the joint distance, the loads acting on it, and the shear force, and the bending moment diagram. Now if you want to see the detailed analysis, go to detailed report, this. So what you can see is the detailed report will be, the detailed calculation will be available. Now if you want to see the deflection plot, you can come over here and see for the deflection plot. And if you want to see, so this is exaggerated view, don't get overwhelmed. So if you want to see the actual deflection, you come over here, displacement is set, this is centimeter, only minus 1.5 centimeter deflection. So the deflection plot SACS actually exaggerates. If you want to see is, if you want to reduce the acceleration, you can select the shape factor and reduce it. Now let's say if you want to redesign, you can always select a different section. Now from library I am selecting a different section, and I'm looking. So for the beam, if I go for a 1 MW for 499, what will be the UC? I can select the recalculate. It will show what will be the UC over here. So UC reduced, this is a bigger beam. Now let's say if I go to W1279, recalculate. So this is like 0.65 is the maximum ratio. So it goes on like that. If you want to change the yield strength, and you can always check. So 245 MPa. So you can always do the redesign from here. So that's an introduction, and we will see you in the next class.